Hey, good morning, paratroopers. Science Saturday. And it's a science fiction Saturday because my camera keeps fading. I don't know how to get it to lock better to keep whatever going. Oh, stop it, you. We'll see what the recording looks like. Anyway, fresh cup of coffee. So let's think about LIGO. And the science LIGO is doing right now is pointed towards interstellar gravity waves. So, and we've pretty high assurance we've found them, we've seen them come and go. But LIGO, capital L, capital IGO, is not a single detector. It's not a single location. It is a global data analysis program that has multiple sensors across the planet, and those sensor numbers keep getting added onto. So what we understand is LIGO has the ability to see a gravity wave created by a massive supernova or some other event in space. So that is amazing. And what that is signal discrimination. It is very advanced signal discrimination. When a tractor trailer drives by LIGO, the sensors will sense that. They will record the tractor trailer driving by, and that is subtracted as background noise. So this is a kind of a very easy signal discrimination technique where you have a known background and you just flat subtract it from whatever information you've got, and the rest of that signal is what you're looking for. So this is signal discrimination. It is identification, friend or foe. It is ways of interrogating data that requires huge amounts of information. So now we get into GIS information and what that is, right? Basically, I said somewhere else that GIS is geospatial information set, or a number of other acronyms you can break those letters out into. But it is very specific time and location tagged information so that it can be compared to another location or another time, and that signal is very distinct, right? It's gravity. So anything that the detector sees besides gravity, and it sees whatever's in its nature to see, right? In this case, it's vibrations. It's basal vibrations from outer space. Is that what that's measuring? And we've gotten the precision of that measurement. We've gotten to that precision because we can understand electron orbitals and sense them. We still can't really see them. That's all CGI, but that's the amazement of what's inside these huge information sets, and why to visualize it for us. We are visual creatures. I can't imagine not having sight, but I can because people are blind. I need glasses. I have to have glasses now to read. So what does that have to do with LIGO? Not a whole lot, other than if you want to understand what LIGO is trying to show us. It takes these huge data sets to create one pixel on a display, one color out of the color table. And who assigns that color? So that's done in computers, but software does that was written by people so that people could understand the information they were trying to display. So this LIGO thing is really huge. really massive data sets. And right now, those detectors, whatever they detect, have everything we know about subtracted from them. Again, information processing. It's encrypted information, so we have to decrypt it if you want to use that as a context or a thought about how much data is sitting out there. The funding that LIGO got is almost pure supercomputing power and some instrument upgrades, but that so much data comes off of those detectors. It is in the petabytes, and that's one detector location. And right now, I know we have 3. I think there's more coming online across the round globe. And in order to synchronize those, you have to have a clock that's accurate out to how many decimal places? So conversations about math need to be serious if you want to put math in here about proofs. But that's LIGO. Do you need to know all that? No. You need to know how to visualize, how to take data sets and turn them into visual information. And if you can do that, you can turn it into information over time and see the past and see the future. So that's weather prediction scenarios. That's supercomputer land. That is algorithms that were written over for computers that were written over 60, 70 years ago. The beginnings of those were whenever computers began, whenever that tube theory, that binary processing that allowed, we learned analog processing. Analog stuff is airwaves, AM, FM radio. Old television is analog. Now it's all analog carrying a digital signal. So the analog is still there. Why is LIGO important? Not LIGO, the location in Washington State. It's LIGO, the system, has the ability as well to see inward. And this is my kind of quest, is this inward information. We know so much about outer space. It is impressive. It's amazing. It's awesome. And it's being bastardized for profit. But we know as much about this planet. We don't have the tools to see it. We do have the tools to see it. It's part of research. It's part of what might come out in a journal article 2 years from now. And I'm thinking we can do a little bit better with this. Maybe. Which would be the fascination of the internet, the promise of all those commercial nuclear reactors decades ago to bring knowledge and some information to people in a different way. So LIGO is important. LIGO should have the ability, to my mind, to see through the planet in a number of different ways at a resolution unimagined by most people. And yet we're doing it. So, yeah. But I think that LIGO could see the magma mass in the core of the planet. Not the core, the surface magma masses. Those are probably more relevant to us because they're more near and likely to do something with us. Those are what help float plate tectonics. That is high pressure physics, geology at its most awesome. It's interferometry, it's base reflectivity of gravitational waves inside our own planet. It's seismic testing, just like we do for oil fields or for out in the ocean, the sonar, the radar. This is a huge information set inside of LIGO that just should be amazing. I am surprised universities aren't clamoring over each other to look inward, the same way they aren't clamoring over each other to look at health issues. It's not that we don't do these things, it's that I guess we don't do these things in the real world. Stay atheist, stay agnostic, stay humanist, stay realist, stay faithful, stay true, stay woke. Can you use that word anymore? Oh no. Anyway, if you're listening this far, God bless you.